Hello viewers, in my previous video I have explained the sums of 12a and today I am going to start 12b. But before starting, let me give you the basic idea about sector, arc length and segment. Now what is a sector? Sector means it is a portion of a circular region enclosed by two radii and the corresponding arc. As you can see, this is a circle, this is one radius, this is another radius and this is one arc. The region between these two radii and the corresponding arc is called the sector. Now, if I draw, suppose if I consider this one, this angle is 180 degree, then this part is called semicircle. Now, in case of semicircular region, angle is 180 degree. If this angle is less than 180, then whatever region we will get, that region is called minor sector. And if it is more than 180 degree, then it is called major sector. And this theta is called the angle of the sector. I hope what is a sector, minor sector and major sector are now clear. We know area of a circle is pi r square and the circumference of a circle is 2 pi r. That means this boundary is 2 pi r and the area of the circular region is pi r square. Now suppose this is one sector, here radius is r, angle is theta, and we want to find the area of this region. That means area of this sector. Then how to find it? We know when this angle is 360 degree, then area of the circle is pi r square. So if central angle, that means if this angle is 360 full angle, then it will be the circle, and we know area of a circle is pi r square. So here I have written if central angle is 360 degree, then area is pi r square. We know area of a circle is pi r square. And now if I consider angle to be 1 degree, if central angle is 1 degree, then area will be pi r square divided by 360. And if central angle is theta, because here angle is theta, it can be 30, 40, 50, anything. So if central angle be theta, then area will be pi r square theta by 360. That means area of a sector is pi r square theta by 360. So this formula we are going to use in many sums of 12b. Now we know the circumference of a circle is 2 pi r. That means when angle is 360 degree, we know this full angle is 360. If this angle is 360, then this length is 2 pi r. That much we know. So if central angle is 360 degree, then length of the arc will be 2 pi r, because circumference of a circle is 2 pi r and we know circumference is the boundary of the circle. Now if the angle is 1 degree, then length of the arc will be 2 pi r divided by 360. We are just using unitary method. Now here we have considered angle to be theta. If central angle is theta, then length of the arc will be 2 pi r theta by 360. And if I cancel 2 and 360, we are going to get pi r theta by 180. Therefore, arc length, that means from here to here, this length is pi r theta by 180. This is the formula of arc length. So we got area of a sector is pi r square theta by 360 and arc length L is pi r theta by 180. Now what is the segment? Suppose this is a circle and if I draw a chord, then this region is called one segment. Definition wise we can say portion of a circular region enclosed between a chord and the corresponding arc is called segment of a circle. So in this circle, this is the chord and this is the arc, and the region between this chord and the arc is called segment. Now ACB is called the minor segment and ADB upper part is called the major segment. Now in this circle ACB is the segment. Suppose radius is r and angle here is theta. Now how to find the area of the segment? To find the area of the segment, we have to draw two radii. Then if I subtract area of the triangle from the area of the sector, if I subtract area of the triangle from the area of the sector, then I am going to get area of the segment. Now area of the segment here is area of sector OACB. OACB. If I consider the full sector and from this sector, if I subtract area of the triangle OAB, that means area of a segment is area of the sector OACB minus area of the triangle OAB. Already I told you the area of a sector is pi r square theta by 360, and whenever one triangle is there with radius r and angle theta, then area of this triangle will be r square sine of theta by 2 cos of theta by 2. Here suppose angle is 60 degree, then we have to consider sine of 30 cos of 30. If it is 90 degree, we have to consider sine of 45 cos of 45, because here theta by 2 we have to consider. Clear? So area of the segment will be area of the sector minus area of the triangle. It may be a right angle triangle, it may not be, so I cannot consider half into base into height directly. Clear? So from these two, if I take r square common, we are left with pi theta by 360 minus sine theta by 2 cos theta by 2. Clear? Don't write sine of theta whole thing by 2. This is wrong. It should be sine theta by 2 and cos theta by 2. And this is the area of a segment. Now you know area of a sector, arc length and the area of a segment. So now I am going to start sums of 12b. In 12b, question number 1 is find the area of the sector of a circle of radius 8 cm and angle at the center is 30 degree. Here radius is 8 cm and central angle is 30 degree, and we have to find the area of this sector. That means this part's area is to be calculated. Now here radius is 8 cm, angle at the center as given in the question theta is 30 degree, and we know the formula area of the sector is pi r square theta by 360. We know pi is 22 by 7, r square radius is 8, so it will be 8 into 8, theta is 30 degree by 360. Here it is better to write 360 degree, here also 30 degree. Clear? Now 22, this 7 can be written in the denominator, so 22 by 7 into 8 into 8 into 30 degree by 360. If I cancel 30 and 360, I am going to get 12. So 22 into 8 into 8 divided by 7 into 12. Now this 22 and 12 can be cancelled. If I cancel with 2, I am going to get 6. And if I cancel with 2, I am going to get 11. So now we are left with 11 into 8 into 8 divided by 7 into 6. Now if I cancel 8 and 6 by 2, I am going to get 4 here and I am going to get 3 here. So we are left with 11 into 4 into 8 divided by 7 into 3. So 11, 4 into 8, 32, 3 7 is 21. If I multiply 11 and 32, I am going to get 352 by 21. If 352 is divided by 21, it will be 16.761. On rounding, it will be 16.76 centimeter square. Therefore, area of the sector is 16.76 centimeter square. And be careful while writing the unit, since it is the area, so it will be centimeter square. I hope this sum is clear. Let me explain question number 2 now. To first part, the question is a chord of circle of radius 14 centimeter subtends a right angle at the center. What is the area of the minor sector? Here radius equals to 14 centimeter, because this from this point to this point, this distance is 14, and as given in the question, angle at the center is 90 degree. Now we have to find the area of this portion. Now we know area of the sector is pi r square theta by 360. Pi is 22 by 7, r square radius is 14, so it will be 14 into 14, theta is 90 degree by 360 degree. Clear? So in the next line we can write 22 into 14 into 14 into 90 divided by 7 into 360. This 7 can be written in the denominator. Now 90 and 360 can be cancelled, we got 4, and 7 and 14 can be cancelled, we got 2. So we are left with 22 into 2 into 14 divided by 4. Now these 4 and these 2 can be cancelled, we got 2, and these 2 and 22 can be cancelled, we got 11. So we are left with 11 into 14, and 11 into 14 is 154. Therefore 154 centimeter square is the area of the minor sector. Now second part of question number 2, a chord of circle of radius 14 centimeter subtends an angle 60 degree at the center. Find the area of the major sector. In the previous sum it was minor sector, and now we have to calculate major sector. As given in the question, here radius is 14 centimeter, That means from here to here, this distance is 14 centimeter. And in the question it is given that angle of minor sector is 60 degree. That means this angle is 60 degree. But we have to find the area of the major sector. And that means this is the part whose area is to be calculated. For this part, this angle will be, total angle is 360. So 360 minus 60, this part will be 300. That means this angle is 300 degree. We can write here angle of major sector theta equals to 360 minus 60. That means 300 degree. Now we have to find the area of the major sector. Formula will remain same. Pi r square theta by 360. Pi is 22 by 7 into r square 14 into 14. Theta is 300 by 360. Now I have written 22 into 14 into 14 into 300 divided by 7 into 360. This 7 we have written in the denominator. Now this 0 and this 0 can be cancelled. 7 and 14 if I cancel, I am left with 2. So we are left with 22 into 2 into 14 into 30. So 22 into 2 into 14 into 30 divided by 36. Now if I cancel by 3, 3 10 ja 30, 3 12 ja 36. So we got 22 into 2 into 14 into 10 divided by 12. These 2 and 12 can be cancelled. We got 6. So it will be 22 into 14 into 10, 140 by 6. These 22 and 6 can be further cancelled with 2. Here we got 3 and here we got 11. So we got 11 into 140 divided by 3. 11 into 140 will be 1540 by 3. If I divide, I am going to get 513.333 centimeter square. On rounding, it will be 513.33 centimeter square. Therefore, area of the major sector will be 513.33 centimeter square. And that's the answer. I hope this sum is clear. Now let me explain question number 3. Now question number 3 is, find the angle subtended at the center of a circle of radius 5 cm by an arc of length 5 pi by 3 cm. Here arc length is given, radius is given. We have to find the angle subtended at the center. As given in the question, here radius is 5 cm, arc length is 5 pi by 3, and this angle, that is center angle theta, is to be calculated. So I have written radius equal to 5 cm. Length of the arc L is 5 pi by 3. It is given in the question and this is given in centimeter. We have to find angle subtended at the center. That means theta is to be calculated. We know arc length L is theta by 180 into pi r. Now L is given in the question 5 pi by 3. Theta is not known by 180 into pi into 5 because radius is 5. Now we have to calculate theta. So we'll keep theta in one side. So we got 5 pi into this 180 will be in the numerator and 5 pi will be in the denominator. So 5 into pi into 180. This 180 if I cross multiply, it will go in the numerator. So we got 5 pi into 180 and here 3 into pi into 5. Now this 5 and this 5 can be cancelled. This pi and this pi can be cancelled. So we got theta equals to 180 by 3 and 180 by 3 is 60 degree. Therefore, angle subtended by the arc at the center is 60 degree. I hope this sum is clear. Let me explain the next sum, that is question number 4. Question number 4 is, an arc of length 20 pi centimeter subtends an angle of 144 degree at the center of the circle. Find the radius of the circle. So quite similar sum. Here also arc length is given. Here angle is given and we have to find the radius of the circle. Let 8 centimeter be the radius of the circle and here arc length is given as 20 pi centimeter and angle at the center is 144 degree. We have to find the radius of the circle. So we can write here, let 8 centimeter be the radius of the circle. Here length of the arc L is 20 pi as given in the question and angle at the center theta is 144. So this 144 degree angle at the center is given, arc length is given and we have to calculate radius of the circle. We know arc length formula is theta by 180 into pi r. Arc length is given as 20 pi equals to theta is 144 by 180 into pi into r. Here we have to calculate radius. So we'll keep r in one side. So we got 20 pi. This 180 if I cross multiply, it will be in the numerator and 144 and pi will be in the denominator. This pi and pi can be cancelled. So we got radius equals to 20 into 180 by 144. Now, if I cancel 180 and 144 by 2, I am going to get 90 here, and here it will be 72. Now we are left with 20 into 90 by 72. Now if I cancel 20 and 72 by 2, here it will be 10 and here it will be 36. Now we are left with r equals to 10 into 90 by 36. If I cancel 90 and 36 by 3, here it will be 30 and here it will be 12. Now we are left with 10 into 30 by 12. Cancel by 3, it will be 10, it will be 3 4 12, so it will be 4. So we got 10 into 10, 100 by 4, and 100 by 4 is 25. Therefore, radius of the circle is 25 centimeter. So we got radius is 25 centimeter, and that's the answer. Now let me explain the next sum, that is question number 5. What is the perimeter of a sector of angle 45 degree of a circle with radius 7 centimeter? And here it is given, we have to take pi as 22 by 7. In this question it is given that angle subtended is 45 degree, radius is 7 centimeter, and we have to find the perimeter of this sector. Now here angle subtended at the center is 45 degree, so theta is 45 degree. Radius is given in the question, radius is 7 centimeter, and we have to find the perimeter of the sector. Now perimeter means boundary. Here this part is radius, that is r, this is also radius, and this is pi r theta by 180. So what is the perimeter of this sector? It will be twice r plus pi r theta by 180, r plus pi r theta by 180. So we have written here perimeter of sector is twice r plus theta by 180 into pi r. This is the radius part and this is the arc part. Now from here I can take r common. If I take r common, we are left with 2 here plus, since I have taken r common, we are left with pi theta by 180, 7 because radius is given as 7, here 2 plus theta as given in the question 45 degree by 180, and pi is 22 by 7. 45 and 180 can be cancelled, we got 4 here. So we are left with 7, then 2 plus 1 by 4 into 22 by 7. This 4 and 22 can be cancelled with 2. Here we got 2 and here we got 11. So 7 within bracket 2 plus 11 by 7 to the 14. So 7 LCM will be 14. Since here it is 1, 14 divided by 1, 14. 14 to the 28 plus 14 divided by 14, 1. 1 into 11, 11. So 7 into 28 plus 11 is 39. 39 by 14. Now 7 and 14 can be cancelled. 7 to the 14, so I am left with 2. So it will be 39 by 2, and 39 by 2 is 19.5 centimeter. Therefore, perimeter of the sector is 19.5 centimeter. I hope this sum is clear. And now I will explain next sum, that is question number 6. In question number 6, it is given AB is chord of a circle with center O and radius 4 centimeter. AB is of length 4 centimeter and divides the circle into 2 segments. Find the area of the minor segment. As given in the question, AB is a chord of a circle with center O and radius 4 centimeter. AB is of length 4 centimeter and divides the circle into 2 parts. This is one part, this is another part. That means there are 2 segments. Now we have to find the area of the minor segment. That means this area is to be calculated. Clear? But here the central angle is not given. So suppose r centimeter be the radius of the circle. So we can write, let r centimeter be the radius of the circle with center O and angle subtended at the center be theta. So this angle be theta. Now here AB is 4 centimeter. Radius is also 4 centimeter. That means OA equals to OB equals to AB. This is 4 centimeter. This is 4 centimeter given in the question. This is also 4. Since all the sides are equal, triangle must be equilateral triangle, and we know each angle of an equilateral triangle is 60 degree. Therefore theta is 60. So we can write here OA equals to OB equals to AB. All are 4 centimeter. Therefore triangle ABO is an equilateral triangle, and we know each angle in an equilateral triangle is 60, therefore theta is 60. Clear? Now since we know theta and radius, we can calculate the area of the segment. We know area of the minor segment formula is pi theta by 360 minus sine theta by 2 cos theta by 2 into r square. I have shown this formula before. Pi theta is 60 degree here by 360 minus sine theta is 60, so it will be 60 by 2 cos 60 by 2 into r square. Radius is 4, so it will be 4 square. Now 60 and 360 can be cancelled. We got 6, so we are left with pi by 6 minus sine 60 by 2. 60 by 2 is 30 degree and 60 by 2 here 30 degree. So pi by 6 minus sine 30 degree cos 30 degree and 4 square is 16. Now pi by 6 minus sine 30 value is 1 by 2 into cos 30, it is root 3 by 2 into 16. So pi by 6 minus root 3 into 1 root 3, 2 2 ja 4 into 16. Now pi by 6 into 16 minus root 3 by 4 into 16. Now 6 and 16 can be cancelled with 2. We got 8 by 3, and here 4 and 16 can be cancelled. We got 4. So we are left with 8 pi by 3 minus 4 root 3 centimeter square. Now if you want, you can replace root 3 by 1.73. But as it is not given in the question, you can keep the answer up to this much. Therefore, area of the minor segment is 8 pi by 3 minus 4 root 3 centimeter square. And that's the answer. I hope the sum is clear. And that's all for today. In my next video, I am going to explain from question number 7 onwards. Till then, bye bye, take care and wait for the next video.